let's continue discussion about the Fourier series. So last time we defined yung Fourier series as a function, piecewise continuous function on this interval from negative pi to pi. So then the Fourier series of the given function is a series in this form, and we derived the formula for a sub naught, no? So this is the formula. So it's equivalent to 1 over 2 pi times the integral from negative pi to pi f of x dx. Similarly, we have the formula for the other coefficients such as a sub n and b sub n are called or considered as the Fourier coefficients of the given function f, no? So we have here this theorem for your convergence. If the function is a periodic function with a period of 2 pi and f prime are piecewise continuous on this interval from negative pi to pi, then the Fourier series is convergent, no? The sum of the Fourier series equals to f of x at all number x where f is continuous, at the number x where f is discontinuous. The sum of the Fourier series is just the average, no, of the right and left side limit. That is 1 half times f of x to the right plus f of x to the left. Now, if we're given a function with a period of 2L, okay, kasi last time we can determine the Fourier series of the given function if the period is from negative pi to pi. No? So this time, the period is defined as 2L. Okay, where of course L here is considered as can be any real number. No, so if f is a piecewise continuous function on this interval from negative L to L, its Fourier series is equivalent to this expression where a sub naught is equivalent to 1 over 2L times the integral of f of x dx from negative L to L. And for n should be greater than or equal to 1. And a sub n is equivalent to 1 over L times the integral from negative L to L f of x cosine n pi x over L dx. And similarly, for b sub n, okay, so we have here 1 over L times the integral from negative L to L of x sine n pi x over L dx. Okay, so for example, so our task here is to find the Fourier series of this triangular wave function defined by f of x is equivalent to the absolute value of x, for which they're given here the domain from negative 1 to 1, and f of x plus 2 equals f of x. So this 2 here represent the periodic value, no? So yung periodic value represent yung one complete cycle. So this value 2 can be equated to the periodic value p. So annotate lang natin. Okay, so p natin is, so yung period is equivalent to 2. Okay, so this value 2 here can be equated to the periodic value which is 2L. So by equating this 2, we can determine here the, of course, the value of L, which is result to be equal to 1. No? So simply divide both sides by 2. So the graph of the function is as shown here. Okay. So just to illustrate, ito yung one complete cycle, no, from negative 1 to 1. Okay. So yung value niya is 2. Kasi this is 1, this is also 1. No? So just take the absolute value, this will give us 2. So we expect that this one complete cycle will repeat sa left side and also sa right side. No? Okay. Any questions sa graph? Wala. Okay, so let's proceed now. So to determine the Fourier series of this given function, okay, so we, of course, we define what are the coefficients, yung starting with the first coefficient, which is the a sub naught, no? Okay, so L value is 1. Okay, so yung formula natin for a sub naught, if we try to recall, so yung formula natin is a sub naught equals 1 over 2L. So L to, no? Times the integral from negative L to L, f of x dx. Okay, so since the value of L for this given example is 1, so 1 times 2, of course, is give us a value of 2, no? Okay, so we have here the coefficient 1 half, no? Or constant. Then times the integral from negative 1 to 1. Then the given function is the absolute value of x, no? Okay, dx. So for this case, we can define the given function absolute value of x absolute value of x as, so it's either negative x or x lang yan, no? So yung x natin is from negative 1 to 0, and sa positive x naman natin from 0 to 1. Okay? Kasi, di ba, if you try to recall, so yung graph natin is ganyan. Okay? So this is negative 1, this is 0. So we can define yung negative x as this line from negative 1 to 1, negative 1 to 0, and positive x from 0 to positive 1, this line. Okay? So we can simplify this as is equivalent to, so we have here the constant value, 1 half, then times the integral from negative uh, 1 to 0. So we can break down this given function as piecewise from negative 1 to 0 and 0 to 1. No? So within this interval, the function is defined as negative x, okay, dx, then plus. So we need to distribute, of course, this 1 half to the two terms, no? From negative 1 to 0, then 0 to 1. So you have here again a 1 half value. Then times the integral from 0 to 1. Then our function is defined as x dx. Okay? Any question on this part, class?
Wala po.
Okay. So we can actually evaluate this, no? So this turns out to be equal to 1 half. Okay? Kasi if we try to compute, so starting sa first natin, ito muna, this one. So this is, so 1 half. Okay, we can, of course, factor out yung negative sign. So as if we're evaluating negative 1 to 0, x dx. Okay, so this will give us, so direction natin, plus 1 half 0 to 1 x dx. So negative 1 half, this is x squared over 2, no? Diba? Evaluated from negative 1 to 0. Then plus 1 half. This is, or bracket na lang to, x squared over 2 from 0 to 1. Okay? So upper limit minus the lower limit, starting with this. So negative 1 half. So this is, upper limit is 0, no? So 0 squared over 2 minus negative 1 squared over 2. Okay. Then plus 1 half 1 squared over 2 minus 0 squared over 2. So of course you can eliminate this. Okay. So this will give us negative 1 half. This is negative 1 raised to 2 is positive 1. And we have a negative sign. So negative 1 half. Okay. Plus 1 half. This is 1 half. So this is positive 1/4, no? Tama? Negative times negative is positive. This is also 1/4, no? So 1/4. So of course 1/4 plus 1/4 is 1 half. Okay. So this is the value of a sub naught. Okay. Question so far, class? So clear ko na yung drawing, no? So after a sub naught, so the next coefficient that we need to uh, evaluate is the a sub n, no? So yung formula natin for a sub n, so recall natin. So yung formula for a sub n is a sub n equals 1 over L from negative L to L f of x cosine and pi x over L dx, no? So ang L natin is 1, so that's why we have here 1 over 1. Then times the integral from negative 1 to 1. Our function is defined as the absolute value of x, then cosine and pi x over 1, no? Okay, then dx. So for this case, we're multiplying here. The first function is the absolute value of x, and the second function is this cosine, no? Tama? So this can be simplified as in this form. 2 times the integral from 0 to 1, then times x na lang, then cosine and pi x dxy. Kasi if you try to recall your calculus, we'll anymore further discuss this ano, no, even and odd function. So at this point in time, we already know how to evaluate whether the given function is even or odd, no? So just use this. So take note that absolute value of x is an even function and cosine x is also an even function. So if we try to multiply even times even, the product is an even function. Now, if the function is even, turns out to be an even function, then if you try to evaluate the integral of f of x dx from negative a to a, the result is 2 times the integral of f of x dx from 0 to a na lang, no? Kasi if we try to visualize, if we're given a function like this, okay, we're evaluating the integral from negative a to a, okay? So we need to determine here the, of course, the area of this function under this curve, no? In shaded area. So this equivalent as if we're evaluating, of course, the same function from 0 to a na lang. Kasi this is symmetric with respect to the y-axis. So that's why we have our multiplier 2. So the integral from f of x dx from 0 to a, then times 2, this will give us the same area. Okay? Now, if the function turns out to be an odd, then if you try to evaluate this turns out to be 0 kasi if we try to visualize, so let's say this is the given function. We're evaluating the function from negative a to positive a. So whatever the area, okay, from negative a to 0, this turns out to be negative area plus the positive area. This turns out to be, of course, 0. Okay, tama? So yung area dito will just simply negate this area. That's why this is 0. Okay, can you follow?
Yes po, sir.
Okay, so clear lang natin to, no? So going back sa function, so yung function natin kanina is, I think, ito, no? Okay, so even times even, so the result is even. So it's equivalent to 2 times the integral. So yung limit natin initially is from -1 to 1, di ba? Positive 1. So obviously the a value here is 1, no? So that's why from 0 to a is just from 0 to 1. Okay? Then from 0 to 1, our function is defined as x na lang. Okay? Kaya this is x na lang, then times cosine n pi x dx. Okay? So recall your calculus, IBP, integration by parts. Okay? So we can let a variable u as x. So ang u natin dito is, so ang du natin is of course dx. Ang dv natin is cosine n pi x dx. Okay? So ang result ng v natin dyan would be 1 over n pi sine n pi x. Okay? So ang function natin is 2, 0 to 1, x cosine n pi x dx. Okay? So we need to use the integration by parts. Yung u dv equals uv minus v du. Okay? Okay, so this will give us the a7 value as 2 kasi we have here a constant value to factor out, no? Then times, so dito mag-start yung uv. So ang u natin is x. Ang v natin is 1 over, ito, x times 1 over n pi sine n pi x dx from 0 to 1. Then minus, okay, the integral of v du. So ang v natin is ito. So we can factor out this 1 over n pi. Okay, so we have here a constant value 2 here since we need to distribute the 2 here. Kasi this one uh, can be break down into two terms, no? So that's why we need to distribute the 2 here. Okay, so this we have here negative sign. That's why we factor out -2 over n pi, no? Then times the integral from 0 to 1. Okay, then our v here left here is sine n pi x dx. Okay, so we need to evaluate in first term muna. So if we try to evaluate this first term, this turns out to be 0. And this one, if we try to evaluate this turns out to be equal to this term, no? Kasi let's try to evaluate this one. So sine n pi x dx. Okay. So this is same as sine u 1 over n pi du. Kasi we can let the variable u as n pi x such that du is n pi dx. Okay. So if we try to factor out dx, this will give us 1 over n pi du. Okay. Tama? So we can factor out 1 over n pi. So sine u du na lang yan, no? Okay. What is the integral of sine? Ano ba integral ng sine? Negative cosine u, di ba? Tama? So this will give us, we can factor out the negative sign. So negative 1 over n pi, then times cosine, cosine, wait lang, cosine n pi x, okay, evaluated from 0 to 1. So this will give us negative 1 over n pi times cosine, substitute natin yung 1 sa x. So n pi na lang to. Then minus cosine ng 0. So what is cosine 0? This is always equivalent to 1. Okay, so magkakaroon tayo dito ng negative 1, no? And of course, if you try to evaluate this first term natin, ito, okay, so upper limit minus the lower limit, this will give us 2 times 1 over n pi sine n pi minus, so sinag-shoot natin yung 1, no? So 0 naman, 1, 0 over n pi sine 0 yan. Okay? So of course, sine ng n pi is always 0 yan, diba? If n is equals to 1, we're evaluating sine of pi. Sine of 180 is 0. If n is equals to 2, we're evaluating sine of 2 pi, which is always equal to 0. So this is 0. This is, of course, 0 din to. Tama? So of course, 0 minus 0 is 0 times 2 is 0. Okay? Then minus 2 over n pi. Okay, then times, okay, yung result nito, no? Ito yon. Okay? Then if you try to evaluate, this turns out to be equal to this term na lang. Okay? Kasi if you try to multiply this one, so negative 1 over n pi cosine n pi minus 1 to this term, negative 2 over n pi, this will give us positive, no? Positive 2 over n squared pi squared, then times cosine n pi minus 1. Okay, can you follow?
Yes,
Yes po,
sir.
sir.
Okay.
Yes.
So of course, yung cosine n pi, we have two possible values dito, no? Kasi if n is equals to 1, we're evaluating cosine of pi. Cosine of pi is negative 1. If n is equals to 2, we're evaluating cosine of 2 pi, which is equivalent to 1. So possible values is either negative 1 or positive 1, no? So back ko lang, then we need to remove the drawings. Okay. So ito na yung value ng a sub n, no? Okay. So the next coefficient is b sub n. Okay. So sa b sub n, ang formula natin is b sub n is 1 over L, negative L to L. So f of x, so similar siya sa b sub a sub n. So ang difference lang is instead of using cosine, use the sine, no? So n pi x over L dx. Okay, so again, the given function for this given example is absolute value of x. Our L here is 1, so 1 over 1, the integral from negative 1 to 1. Okay, this is the absolute value of x times sine n pi x over 1 dx. So absolute value of x is an even function, while sine n pi x is an odd function. Okay. So recall, so even times odd is odd, no? Okay. So if the product is odd or the function is odd, then if you try to evaluate the integral from negative a to a, for this case, negative 1 to 1, okay, so f of x represent yung product ng two function, dx, this turns out to be equal to 0. Okay, so this is why the result of b sub n turns out to be equal to 0. Okay, so that means to say that if b sub n is 0, it follows that b sub 1 is 0, b sub 2 is 0, b sub 3 is 0, since our n here will run from 1 to positive infinity. Okay, so we could therefore write the given series as in this form. Kasi, di ba, if we try to recall, yung Fourier series natin is in this form. A sub n plus the summation ng n equals 1 to infinity. A sub n cosine ng n pi x over L plus b sub n sine n pi x over L. Okay? So, a sub n value, we already evaluate that. So, this turns out to be equal to 1 half kanina, di ba? And a sub n is equivalent to 2 over n squared pi squared cosine n pi minus 1. So, ito na yan. Okay? So, of course, we need to multiply the a sub n coefficient to cosine. So we have here cosine n pi x, of course, our L is 1, no? So over 1. Then plus, so of course, if b sub n is 0, turns out to be 0 times whatever value ng sine n pi x over L turns out to be 0. Okay, so no need to write uh, this term, no? Okay, so our n here will run from 1 to infinity. Okay, can you follow? Kaya pa? Yes?
Yes, sir.
Okay, so konti pa. Okay, so clear ko muna. Now, if you try to evaluate, okay, yung cosine, this term, okay, yung may a sub n value. So, again, if you try to evaluate cosine n pi, this is equivalent to 1 if n is even, and if n is odd, cosine n pi turns out to be negative 1, no? So, if we try to simplify this further, so ang a sub n value natin is either 0 or negative 4 over n squared pi squared. So this turns out to be 0 if n is even, and if n is odd, 1, 3, 5, this turns out to be negative 4 over n squared pi squared. So you can obtain these two values by substitution, no? Kasi if n is 1, okay, so going back to this, so yung a sub n value natin is 2 over 1 squared pi squared. Cosine ng pi is negative 1, tama ba? So negative 1, then minus 1. So this will give us negative 4, 1 squared pi squared. Now if n is equals to 2, this will give us 2, 2 squared pi squared. Cosine ng 2 pi is what? 1. Tama ba? So 1 minus 1, this turns out to be 0. 0 times 2 over 2 squared pi squared is, of course, 0. If n is equals to 3, this will give us 3 squared pi squared. Cosine ng 3 pi is negative 1 minus 1. So this will give us negative 4, 3 squared pi squared. So as you can see, we can generate here a pattern. So cosine of 4 pi is 1 minus 1. 1 minus 1 is, of course, 0. So as you can see, if n is even number, 2, 4, 6, okay, so the a sub n value turns out to be 0. Now, if n is odd, 1, 3, 5, so the a sub n value turns out to be equal to negative 4 over n squared pi squared, no? Kuha ba yan?
Yes po, sir.
So admit lang. Okay, so therefore we can rewrite the Fourier series as in this form. Okay, so kasi kanina is, yung form natin is ito, no? Okay, so we can further simplify this a sub n as yung kanina, either 0 or negative 4 over n squared pi squared. So 1 half yung value ng a sub naught. Okay, then if n is equals 1, the n is considered as an odd number. So we can be able to determine the a sub 1 value as negative 4 over 1 squared is of course 1, then pi squared. Then of course we need to multiply the a sub 1 value to cosine ng ito, cosine ng pi x. Yan. Kaya meron tayong a sub 1 value is multiplied to cosine pi x. Okay? Then plus, of course, after n is equals 1, the next value of n is 2, no? So 2 is considered an even number. That's why the a sub 2 value is 0 times cosine ng 2 pi x is turns out to be 0, no? So the next value of n would be 3 na, no? So if n is equals to 3, we can be able to determine the a sub 3 value as negative 4 over 3 squared, that's 9 pi squared. Then multiply it by cosine ng n pi x, or n here is 3, so 3 pi x and so on. Okay, so we can generate this expression, no? So as you can see, we can further simplify this as this form, where 2k minus 1 represent yung odd number, no? Okay, so where k here will run from 1 to infinity, just like the n value. Kasi we have here the pattern after the 1 half coefficient, 4 over odd number squared times pi squared, then times cosine odd number pi x. Okay, so the triangular wave function is continuous everywhere, and so according to the Fourier convergence theorem, then we can state the f of x as in this form for all x, or we can define the domain from negative 1 to 1. Okay, since the given function here is the absolute value of x. Okay, any question, class? Clear ko muna yung drawing. Yan. Question. So bago tayo mag-proceed sa announcement,